This is the Bay of Fundy, located between New Brunswick and Nova Scotia in Canada. It's famous for having the highest tidal range in the world, with tides rising and falling up to 16 meters. Its funnel shape and geology allow it to do so. This question was inspired by the James Stewart Calculus 8th edition early transcendentals. So, at Hopewell Cape, the water depth at low tide is about 2 meters, and at high tide it is about 12 meters. The natural period of oscillation is about 12 hours, and on June 30th, 2009, high tide occurred at 6:45 a.m. Find a function involving the cosine function that models the water depth, d of t, in meters, as a function of time, in hours after midnight on that day. So we can solve for our variables where a is the amplitude. The amplitude of a function is simply the maximum distance between its midline and its highest or lowest point. D is the midline, and the midline is just a horizontal line around which the wave oscillates. And C is just the phase shift, or the time of the tide. The amplitude A is just equal to the maximum and the minimum divided by 2. So that's just 12 minus 2 divided by 2 is equal to 5. And the midline D is just equal to the maximum plus the minimum divided by 2. So in other words, just the average of the highest and lowest values, which is just equal to 7. And C is just equal to 6:45 a.m., which is just equal to 6.75. I also forgot the period T, which is simply 12, which represents the time it takes to get from the lowest point to the highest point and vice versa. So we can just plug this in to the general cosine formula. It's just 5 times cosine of 2 pi divided by 12 times t minus 6.75 plus 7, and this just simplifies down right here.